A square pyramid of 60 mm side, a square pyramid of 60 mm base side and 80 mm axis, and height of the axis is height of solid, whatever it should be. So let us take it as a square pyramid of 50. 60 is very wide. Let us take it as some 50, and height of the solid is some 80. Resting on its base on ground, resting on its base on ground with one of the edges of the base perpendicular to VP. One of edge of base perpendicular to VP. And it is cut by inclined plane, in such a way that the true shape of the section is trapezium. The true shape of the section is trapezium. Whose parallel sides are 46 mm and 26 mm respectively. Draw the sectional top view, front view, and true shape of the section. So draw its projections. So draw its projections means it's a sectional view, and either top view, front view, or whatever it should be. So here it is going to be cut the solid which is inclined to HP and perpendicular to VP. Then you have to obtain front view and sectional top view and true shape. Okay, so that means projections means front view, comma sectional top view, comma true shape. FV means front view, sectional top view, and true shape. Also determine inclination of the section plane with HP. Also determine inclination of section plane with HP. Okay, all of you know that problem. I just want to erase it, so due to the space concern. A square pyramid of 50 mm base side and height of the solid is 80. Resting on its base on ground with one of the base edges perpendicular to VP. and it is cut by the inclined plane in such a way that the true shape of the section is trapezium, whose parallel sides are 46 and 26 mm respectively. Draw its projections. Projections means front view, sectional top view, and true shape. Also determine inclination of the section plane with HP. Let us assume this was your square pyramid of base side 50, height of the solid is 80. So what is the simple position? It is resting on its base on HP such that one of the base edge is perpendicular. So that means you see this edge is going to be perpendicular to VP. So this edge is parallel and this edge is perpendicular. Okay, the same condition, one of the edges parallel to VP is also same condition, one of the edges perpendicular is also going to be the same condition. Okay, why? Because these two edges are parallel to VP, these two edges are, base edges are perpendicular to VP. Okay, so which will use the true shape, top will use the true shape, and it is comes below XY line. Okay, I start my simple position from the top view. Next, you see this, and it is cut by the inclined plane in such a way that true shape of the section is trapezium. So inclined plane means whether it is inclined to HP or VP, your solid is going to be resting on resting with its base on HP means. So inclined plane means inclined to HP and perpendicular to VP, like this. This was your cutting plane. So this cutting plane is supposed to cut your solid in such a way that when you are seeing from top, you notice the section shape is going to be as like a trapezium. So what is that? The heights are going to be 46 and 26. You know the trapezium, one is having the larger side, one is having the shorter side. So it should become like this. Okay, the trapezium. Okay, it should be like this, for example. Okay, I am supposed to erase this problem. All of you write the given data, okay? Run this problem. So tell me the given data. What is the given data? Square pyramid. Side 30, axis 80, side 50, axis 80. Okay. One edge is perpendicular to VP. So edge means one base edge. Base edge is perpendicular to VP. Next, plane is inclined. So that means section plane is inclined, and U is obtained. U is when your section plane is going to be cut this solid, the true shape is and cut this solid. Solid. True shape is trapezium of 46 by 26. Okay. Now let us start our problem. So we should use the true shape. Top will use the true shape. So it is edge resting problem means one of the edges perpendicular to VP. That was our standard procedure. If we didn't mention that one of the edges perpendicular to VP, but we had to take that edge should be perpendicular to VP. So it is a pyramid. So we are cross joining all the corners to the apex. That is over now. O2. So this is A, B, C, D. Height of the solid is given. What is the height of the solid? 80. Okay. So this point is going to be O1 dash. It is O2 dash. Project these points. Okay. So when you are supposed to see from the front, so this was step 1, step 2. Which points are visible? This becomes B dash of A dash. This becomes C dash of D dash. Okay. Now you can say that we already know that what is it? Your section plane is going to be inclined and cut the solid in such a way that the true shape is going to be the trapezium. So of the side 46 by 26. So I know that it is 26 by 46. Okay. So from this center, I just consider from here I just mark it as 46. This edge is going to be 46 and this edge is going to be 26. He already gives that. So one is 46, one is 26. From this center, I just take your scale, move your drafter scale in such a way that so the two edges are going to be, you are going to see this edge, that is OA and OB edges are going to be cut at a distance of 46 apart, and OD, OC are going to be meet at 26 apart. Okay, so this height is 46, this height is 26. Now I am supposed to join these two. Okay. Now, in this regard, I just mark my numbers as, first of all, what are our numbers which are going to be? So, you are going to be just project this obtained sectional view to the top. That is for the front. I just project these lines. This was the line of projector and it just going to just project it. And this was the line of, it is going to be, these two are going to be cut your cone solid at this particular points. Now you just take your section plane in such a way that it is passing in this manner. It is thicket ends. So this is your vertical trace VT. Okay. Now tell me what are the numbers you are going to be seen. Always start from extreme left. So this point is going to be, so OA, that is OB is going to be visible, which is 1. Next, OC is going to be visible. This becomes your 2. Next, we are going to be reverse our direction from the end position starting from left to right. So 1, 2, and this is my starting point from the reversal. So this becomes 3. Why? Because OD edge is there, which is hidden. So that becomes 3, and it is 1, 4. Why? Because OE another edge is hidden, so that becomes the point. Now simply project that points to the respective positions. One point is on OB, so this becomes your 1. 2 point is on OC, this becomes your 2. 3 point is on OD, so this becomes 3. and this becomes 4. So this was going to be done with hatching. So this was your sectioned portion. Okay. And what was the portion which is removed? Which portion is to be removed? Portion between observer and cutting plane is removed. So this portion is removed, and this was my retained portion. So that means 1 A, B, C, D, 2, 3 points are going to be visible. So that means bottom A, B, C, D is completely retained. So this portion is retained. That means A, B, C, D is retained. So I just highlight this. A, B, C, D also. Why? Because the base was retained. Removed portion is this. This was retained. Retained portion is to be darkened with the HB pencil. And you can also see that ABCD is existed, 1, 2, 3, 4 existed, and also the lines joining 1A, 4B, okay, 1B, 4A, and 2C, 3D are also existed. So these are also going to be joined. So this was the retained portion. So this we can call it as just front view. So this was sectional top view. Okay. So next one is to obtain the true shape. How can we obtain the true shape? Or we already know that. We already did in yesterday's class also. How can we obtain the true shape? So true shape is nothing but draw the new reference line parallel to vertical trace. Generally, it was to be constructed at here in general, if the space is permissible. Okay. Now the space is not available for me. I just construct my reference line x1, y1 is at here somewhere. So this becomes my new reference line x1, y1. From here, I just draw the perpendicular projectors from all the points. So that means this was the point, and from here it is going to be obtained. Okay. Now what is going to be the next step? So take the distances from the old reference line to the obtained section area. So this was the obtained section area. So take the distances from the old reference line and put it from the new reference line. Let us take first point from the old reference line. So this radius is going to be as taken as radius. The distance from old reference line to 1. This is going to be taken as radius, and take the one projector from x1, y1. I place it here. So that becomes, all of you see. So this was your point 1. Next, let us see point 2 is going to be at here. This was the 2 projector. I just take the distances from here and I just place it here. This becomes my 2. Next, let us play point 3, which is on the same projector. This becomes your 3. Next, let us take your 4. So this was your distance from old reference line. From old reference line to point 4, this is going to be considered, and I just place it here. So this becomes your 4. Now join 1, 2, 3, 4. Okay, and it is going to be done. Hatching is done. So this becomes your true shape. Okay, students, is it clear now? Students, have you understand? So this was very simple problem. First of all, I know the top view of the of the section view is going to be trapezium. So first of all, I just place my trapezium on the top view, which is going to be 46 and 26. This was 46 and this was 26. So what was the base side? Base side is given 50. Okay. Once I obtain this point, I just project it to the front view. Then my projectors are going to be cut your front view of the pyramid at these 2 points. If I draw this line, so this was your cutting plane, and you also had to measure it. What was the inclination with the horizontal? Inclination with the horizontal is to be measured. So this was some theta. So all of you had to measure this theta is equal to. The section plane inclination with horizontal is to be measured and it is to be placed at here. So this was the front view, this was sectional top view, this was your true shape. Make it fast, I just give you 2 minutes, I'll move to the next problem. Students, I am just erasing this. Friends, all of you write the next column. A cylinder of 50 mm diameter a cylinder of 50 mm diameter of base, a cylinder 50 mm diameter base axis 80, axis 80 mm long, is lying on VP, is lying on VP, lying on VP. And one of its generators parallel to HP, and one of its generators parallel to HP and inclined parallel to HP and inclined 30 degrees to VP. Inclined 30 degrees to VP. And it is cut by section plane. And it is cut by section plane perpendicular to HP and inclined to VP. In such a way that the true shape of the section is ellipse. True shape of the section is ellipse of major axis 75 mm. Draw its projections. Draw its projections. Okay, students, a cylinder of base diameter 50 mm and height of the axis is 80 mm long, lying on VP, and one of its generators is parallel to HP and inclined 30 degrees to VP, and it is cut by section plane perpendicular to HP and inclined to VP. So such that true shape of the section is ellipse of major axis 75 mm. So that means, as like the previous problem, here also he just gives that he didn't give the axis inclination. That means section plane, not axis inclination, section plane inclination. So section plane inclination is, if section plane inclination is given, directly we take that section plane at particular angle and we cut this solid. But he didn't give it. But he says that the true shape of the section is going to be obtained as an ellipse having the major axis 75. So I just take them 75 as a radius and I cut this solid to obtain my section plane. Okay, let us see. What was the simple position? First of all, this was the generator. This was the cylinder having end generators. So in previous columns, we see the prisms and pyramids. we are going to be see when your cutting plane is supposed to cut your solid, then wherever the cutting plane is cut, the one of the edge you are going to be having a point for cutting point. But here there are no edges. This was a smooth surface having only end generators. Then what we can do? We just take referral points as we consider for the projection of simple position of solids and solid inclined to both the reference planes. We just consider for obtaining the true shape of the cylinder, we just consider the circle is divided into some 8 number of divisional generators are going to be considered as the cutting points. Wherever your section plane cut those generator, I just consider it as a point. Why? Because there are no edges here. Okay. For obtaining our smooth curve, we just take it like that. So that is only for our reference. Okay. So tell me first of all, what is the simple position? Base diameter axis is lying on VP. So base is lying on VP. This is the base is lying on VP such that one of the generators are going to be like this. This generator is tilted for an angle of 30 degrees to VP. So 30 degrees to VP like this. So if it is like this, how can you put a simple position? Always in simple version, let's put your axis perpendicular to the reference plane to which it is inclined. Here axis is inclined to VP. So let us put your axis perpendicular to VP. So which view gives the true shape? Front view gives the circle, top view gives the rectangle. Okay, that both the end generators are going to be joined by rectangle. Okay. Let's consider this circle. I just divide my circle into, okay, 8 number of equal divisions for your convenience. For my easy consideration, I just go for only 4 divisions. Okay, let us see. This becomes A dash, B dash, C dash, D dash. You can take 8 number of divisions also for having smooth curve, for obtaining the smooth curve. So for my convenience, I just go for only 4 divisions, but you go for 8 divisions. Okay. So wherever your division is going to be cut by the section plane, you just consider it as a point. Okay. Now this was a cylinder having front base is visible, top base, bottom, behind the another base is there, bottom base, which is given by some P dash. In bracket it is Q dash, R dash, S dash. And this is O1 dash of O2 dash. Okay. I know the cylinder of given of base diameter 50. Okay. Next, when I am supposed to see from the top, so which points are visible? So that is A, B, C are visible. This point is invisible. And I also know the height of the solid is given. Which is 80. Okay. So this axis line is also, I just consider it as one of the generator for reference. Actually for cylinder we just consider only the and the generators only. For my convenience I just take this as also the generator which is going to be visible. Okay. And the points are, let us see what are the points. So front view points are going to, if your cylinder is going to be like this. So this was your front view, top view is obtained on horizontal plane, rotating horizontal 90 degrees. Your visible front view comes to bottom. Okay. So that means ABCD comes at here. So which points are visible? So this is A, this is P of B, and it is C. Okay. Next, similarly, it is P, S of Q, and it is R. Okay. Next, he just gives it as by resting on one of the generator. Is it said that one of resting with one of the base on ground on VP? Cylinder base type if the axis is lying on VP and one of its generators is parallel to HP and inclined 30 degrees to VP. Okay, lying on VP and one of the generators is going to be, that means one of the point is going to be lying on VP and the third means one of the point of the base is going to be touching VP and it is going to be tilted for an angle of 30 degrees. Such that you are supposed to draw your top view which is obtained. So this was your first step, this was your second step. It is to be tilted for given inclination. What is that inclination? Which is 30 degrees. Okay. So draw a line of 30 degrees. Okay. In such a way that I reconstruct the figure in such a way that okay. So this becomes P, S of Q, and it is R. This point is R. Next it is A, P of B, O1, O2. Okay, so this is O2, this is O1, and it becomes C. Okay. Now, so this is your third step. This was step 3. Now draw the vertical projectors from the obtained top view which is tilted. Okay. So from here, draw the vertical projectors. Up to here, this is nothing but your solid inclined to one reference plane. I am doing this solid inclined to one reference plane. Okay. And from here, draw the horizontal projectors. I'll mark the intersection points now. So this is P dash. So this was the second stage. I just considered this was stage 1. So let us give the suffix as some 1. No problem. Okay. These are with suffix 1. These are without suffix. This was the final shapes. Okay. So this was P dash. This was S dash, R dash, Q dash. Similarly, so this becomes A dash, B dash, C dash, that becomes B dash. Okay. Now, what is the farthest point from the observer? When the observer is at here, farthest point from the observer is going to be this. And when the observer is going to be seeing the front, this base is visible, right? So when your solid is tilted for 30 degrees, when you are going to see from the front, so this base is completely visible. So I just join these with the smooth cut. Okay. And from here it is also going to be the smooth cut. And from here it is going to be okay. So this was the cylinder. You just had to join only and the generators. Okay, students. So for your convenience, this is drawn with 2H pencil. This is drawn with 2H pencil. Stage 1. Always stage 1 is to be drawn with 2H pencil. Stage 2 is also if there is sections of solids or projection of solid inclined to, that is also 2H or H pencil. For stage 3, that is nothing but your final front view or final top view drawn with HB pencil. Okay, so this is stage 1. So stage 1 means you just go for 2H pencil only. Next, I just see here, I know that, what I know that, there was a cutting plane which is supposed to cut the solid which is perpendicular to HP. Perpendicular HP means like this. Until now we see this inclined to HP and perpendicular to VP. Now this cutting plane is perpendicular to HP and inclined to VP. So that means like this. Like this, it is perpendicular to HP and inclined to VP like this. In this pattern, it is going to be cut. Okay. So previous it is perpendicular to VP and inclined to HP like this. Now in this pattern, it is going to be cut like this. You just see the difference. So this was inclined to HP and perpendicular to VP. Now this is means inclined to VP and perpendicular to HP. So how can we know the axis of there is inclination of the cutting plane which is supposed to cut this? So that means, so you just get it out. So how can we consider your HT or VT? Sir, cutting plane is comes at here, cutting plane or come here. So it is perpendicular to HP and inclined to VP. So when your inclination to VP means always inclination to VP comes below XY line. That means your cutting plane should be below XY line. Okay, and also it is perpendicular to HP. When it is perpendicular to HP, that should be seen from top only. You see, it is perpendicular to HP. That means it should look like as a line from top. It becomes its horizontal trace HT. Now, true shape of the section is given as ellipse of major axis 75. So you just measure your scale in such a way that when your this major axis means these are the two end generators. If I consider this is going to be the two ends where it is going to be cut with 75, I just consider it as the major axis. Okay. If I just take my drafter on scale, you just move your drafter in such a way that the distance between these two is going to be measured. If you just take a horizontal scale like this, if you just move with this point, it will cut somewhere at here. You will obtain somewhere at here, for example. You move your scale in such a pattern that you are going to be obtain so this becomes its HT. Okay, you just move your scale in such a way that the distance between the two energy generators must be 75. From here to here, it should be 75. Then I just join those 2 points with my cutting plane. So this becomes your inclination. So this becomes your inclination with the. So this becomes your phi generally. You just measure it and you just place it here. So somewhere at phi is equal to like this. Okay, now place the points first of all. Place the points. So always start from extreme left. So PA is going to be one of my edge. So I just consider this point is 1. Next, I just consider SD also. This was the cylinder for obtaining the points. I just have to consider this was also one of the generator and it is supposed to be. Why? Because it is n number of generators. I just consider this is also one of the generator for obtaining the referral point. So SD is going to be the point. So I obtain 0.2. Next, RC is going to be cut at this particular, this point becomes 3. Next, it comes to here, it is, there was QB, this was 4, 2 comma 4, and this was only 1 edge. So if you consider 8 number of points, you are going to obtain 8 points. For example, say for example, here it is also going to obtain, here it is also going to be obtained. There are also 2 points are going to be obtained here, 2 points are going to be obtained. Total you will obtain 8 points. Okay, when you consider the 8 number of equal divisions. Okay, I just consider only 4, I just obtained 4 points. Now project these points to the respective positions. So 1 point is going to be on PA. So let us see, PA is going to be this generator. So project that point to the PA. So if I just project it here, so it comes at somewhere at here, this becomes your 1. Next, 2 point is on SD. So this was SD. Project your 2 point to here. So this becomes your 0.2. So previously here is the cutting plane. From top you are going to obtain the true shape at here. Here it is going to be, cutting plane is going to be below XY. The section view is going to be comes on front. Next, the 3 point is on RC. So this was your RC. So it's somewhere it will obtain it here somewhere. This becomes your 3. Next, 4 point is on QB. So this was your QB. So this becomes your 4. Okay. Now join all the points in sequence. Okay. So you will obtain an ellipse. Okay, students, is it clear? Up to now, is it clear? Now do the hatching for this. So which was the sectioned portion. So it was done with hatching. Always your sectioned portion is represented with the hatching only. Hatching is equally inclined and equally spaced. Okay. So now I just call this as, this was your sectional front view. Why? Because sectional shape is going to be seen from the front. So I just call it as sectional front view. This was just top view. This was top view. Now how can we obtain my true shape? How can we obtain my true shape? Simply, you just draw the new reference line x1, y1, which is parallel to your cutting plane, and draw the perpendicular projectors from all the points. Okay. Now take the distances from old reference line of all the points and put it from the new reference line. So let us see, 1 point is going to be somewhere at here, 1 point. So this becomes your 1. Next, this was your 2 point. So this becomes your 2. Next, this was your 3. and this was your 4. It becomes your 4. Now join all the points. So this becomes your true shape. That means true shape of the section. So that means I just draw the new reference line x1 y1 and draw the perpendiculars from all the points to the new reference line. Take the respective distances from old reference line and put it from the new reference line and join all the points will obtain an ellipse. That was your true shape. Students, is it clear? So I just give you 2 minutes. All of you just do it. All of you just make it copy. Students, can I erase this? Shall we move to the next problem? Everyone, had you copied this? Shall I erase this, students? Can I move to the next problem? No one is responding. Are you drawing it or can I proceed? Had you copied this? A pentagonal pyramid, base 30 mm high, pentagonal pyramid, base side 30 mm and axis 60 mm and axis 65 mm, has its base horizontal resting on HP. The pentagonal pyramid base 30 mm, side base side 30 mm and axis 65 mm, resting its base on HP, resting with its base on HP. So in some way it gives as base is horizontal. Base is horizontal. Base is horizontal means where it is base is horizontal means it should be on HP. And an edge of the base is parallel to VP. edge of the base is one of the edge of the base is parallel to VP. A horizontal section plane cuts at a distance of 25 mm above the base. Horizontal section plane cuts at a distance of 25 mm above the base. Draw its projections. What are the projections means? So here base is resting on HP. So cutting plane should be parallel to, given cutting plane is parallel to its base. So front view you are going to be obtained as simple front view, comma sectional, top view and true shape. So these are to be obtained. Okay. Now put the simple position. So pentagonal pyramid resting with its base on HP. We already know that. How can we put the simple position? XY such that one of the base is going to be, one of the base it is parallel to VP. So that means like this. Your pentagon should be constructed in this manner. Okay. So let us consider the points are A, B, C, D and E. So this was a pyramid. You are going to obtain only one set of points. Now put the axis, that is origin. So that means when you are supposed to see the top, you are going to see the apex. How can you obtain your apex? One of the corner to the opposite side center, one corner to the opposite side center. These two can meet at a common point, that is your apex point. Okay. So height of the solid is given. What is the height of the solid given? Given base side is given as 30. What is the height of the solid given? 65 mm. Okay, so this was 65. Okay, so when you are supposed to see the front, the points are going to be obtained, base is going to obtain on XY. So I just draw the projectors. So generally when you are going to be constructed in this pattern, your axis and your this will going to be meet at the common point and it is going to obtained it here in general. Okay, when you go for the original construction, you see this B is going to coincide with your axis. Okay, so while you are going to be seen from the front, apex is going to be visible, that point is going to be, so this is O1 dash, so this is O2 dash, and front view points are going to be, front view points are, so this was A dash, this was E dash in bracket, this was D dash in bracket, this was C dash, and this was visible point, so this is B dash. Now join O dash with A dash. O dash with E dash, and this was the solid line. Why? Because solid corner is visible from the front, so this B point. Next, this becomes your dotted again. Next, this was the visible solid line. And this was the visible base. Okay. So this was step 1. This was step 2. Next, you will see that horizontal section plane cuts the at a distance of 25 mm from the base, that is above the base. So this height is total 65. Let us take 25 is going to be somewhere at here. This was the point, and your cutting plane should pass in this manner. So this was going to be thick at ends. Okay, this one. This was your PT. Okay, so when the observer is going to be seen in this pattern, top view, which portion is to be removed and which is retained? Portion between the observer and this cutting plane is to be removed, and bottom portion is retained. So that means this was going to be retained. Now tell me the numbering first. So this was the first, always start from the left. So this becomes your 0.1. Next dotted line, least reference. Next, this was a solid line. This becomes your 0.2. Next, this was dotted. Next, this becomes your 0.3. So again, coming in this pattern, which is going to be first? This was your first. So this becomes 4. This was OD dotted. Next, this becomes your 5, which becomes OE dotted. Students, is it clear how I place my numbers? Next, project the points to the respective positions in the top view. So this was the pyramid in general. Actually, in previously I didn't join the top view. The pyramid, all the corners to the apex are to be joined. Next, to project that points to the respective positions. One point is on OA. So project that point to OA. This was your 1. So this becomes your point 1. Okay. Next, 2 point is on OB. So 2 point is on OB. Okay. So which is a straight line. So when it is going to be projected, it comes at here itself. Now if you see, this was the obstacle here. I just get an obstacle. If I just consider my 2 point, so it is going to be obtained here. Now, in this consideration, my 2 point is not to be at here. It should not coincide OB edge. It should cut the solid OB slant edge, but it is coinciding. Now, when the problem arises in this type of situations, you just create a true slant edge. We just had to create true slant edge. All of you just see what is mean by true slant edge, sir. So when your slant edge is going to be in such a manner, for example, if this is going to be XY, if you just draw a line in front of which is inclined, if it is A dash and B dash, if you draw its top view, this becomes your AB. Whenever your top view is going to be parallel to XY, then we can say this is true slant edge. That is your true slant edge. Students, is it clear? So whenever your top view is going to be a straight line parallel to XY, so then your A dash, B dash and AB are going to be considered for the true slant edge. You just remember what is meant by this true slant edge, okay? Then let us see, is there any true slant edges here? Your OC and OA are going to be, this OA and OC generally these are going to be an incline which are not parallel to XY. So in this type of cases, we are supposed to create dummy true slant edge. We are supposed to create dummy true slant edge. How it is possible? Let us see. First of all, all of you just see, this was very important. All of you just see, I just create my true slant edge, dummy true, how it is. From O, I just draw a line parallel to XY. From O, I just draw a line parallel to XY. Next, I take O as center, OC as radius, draw an arc up to here. O as center, OC as radius. So this becomes, let us consider, for my convenience, it is C1. Okay. Now draw the vertical line up to XY. Project this to the XY. So in front it becomes C1 dash. If I just draw a line of O dash C1 dash, okay, now this becomes, what is this becomes here? It becomes, so this is O1 dash and here it is going to be C1 dash, here it is O1, here it is C1. Now I can say that O dash C1 dash is going to be your dummy true slant edge. I just created it. Okay. Once you create the true slant edge, I just project my point 2 on the true slant edge at here, somewhere at here. So this becomes my 2 point. I just project this point onto the true slant edge O dash C1 dash. So this becomes my point 2 now, which is going to be cut at the OC1 dash at particular point. Now from here, I just draw the vertical projector. From here, I just draw the vertical projector. This meets the OC1 at particular point. This becomes my point 2. Okay, so this was for referral point. This was your referral point 2. Now let us take O as center, O2 as radius, draw an arc. O as center, O2 as radius, draw. This becomes your final point 2. O as center, O2 as radius, draw an arc to obtain up to the point on OB edge. Students, is it clear now how you created your true slant edge and how I just projected my point 2 on the true slant edge? Okay, let us see. So first of all, when your point is going to be not to be obtained directly on the one of the edges, let us see whether there is a true slant edge or not. Whether how it becomes true slant edge, when your edge is going to front view is going to be like this, when your top view is going to be parallel to XY, then I can say it is a true slant edge. Then I can project my point to the true slant edge and I shift that point to here and I can rotate to get the point. But here there are no true slant edges. Why? Because so OD, OE, OA, OC, OD, which are not any one of the edges parallel to XY. So in that case, I had to create new true slant edge. How it is possible means simply from O, I just draw the line parallel to XY. I just now create my OC1 is going to be your new true slant edge for a reference. Or you can take in this manner, OA is also going to be rotated. It should become here. It comes like this also. I just created this point. O as center, OC as radius, draw an arc up to this horizontal line which I draw parallel to XY. Okay, O as center, OC as radius, draw an arc up to line which I drawn. So this becomes your C1. If it is C1, when it comes above XY line, it changes to C1 dash now. Now join O dash with C1 dash. So this becomes front view which is a slant edge. And when I am supposed to see from the top, it is going to be your top view. How it should look like? Generally, this was going to be, this was XY. Okay, so this is O dash, this is C1 dash. Okay, if I draw the top view, it should come like this. So this becomes O1, this becomes C1. Now I say that my OC1, O dash C1 dash is slant edge, OC is going to be in top which is parallel to XY. Now I can consider this as the true slant edge. Okay. So once I obtain my true slant edge, I just project my point 2 on the true slant edge. That means you simply draw the same, it is on the same horizontal line. I just place my point at 2 at here. Once you obtain your point, project that point 2 on the OC edge. So this was OC1. So I just project my point to the OC1 that obtained at somewhere at here. Okay? Or you simply consider it as some K also, whatever it should be. Whatever the point you just consider. Now O as center, OK as radius, draw an arc up to OBH, wherever it is cut, you obtain point 2. Okay? Students, is it clear now? Is it okay now? Next, let us see point 3, which is directly on. Point 3 is on OC. If you project point 3 on OC, so you obtain point 3 directly. This is 3. 4 is on, point 4 is on OD. So directly if you project it here, you will get point 4 at here. Point 5 is on OE. So you will obtain point 5. Now join all the points. 1, 2, 2, 3, 3, 4, 4, 5, and 5E. Okay? Next, tell me the portion which is removed and retained. Portion with observer and cutting plane is removed, and this was my retained portion. This was okay. So that means bottom base ABCD is completely retained. So in top view also, which was completely remained. Okay, and 1A, 2B, 3C, 4D, 5E edges are also existed. So these are also drawn with like this. and it was drawn with hatching. Okay, so this becomes your front view. So this becomes your sectional top view, and there is no true shape. There is no need to draw the true shape for this kind of problems when your cutting plane is parallel to the base. Okay, so there is no true shape. Why? Because means when your cutting plane is parallel to base, when you see from the top, you see clearly the true shape. Whenever your cutting plane is inclined only, then there is a need of constructing the true shape separately. But here it is parallel to base. The top view itself gives the clear view. So sectional top view is sufficient for the true shape itself. There is no need to draw the true shape for this figure. Okay. Okay, students, is it clear? There is no need to draw the true shape. Why? Because when your cutting plane is parallel to the base, okay, so there is no need to draw the true shape. So sectional top view is sufficient. So when your cutting plane is inclined means then there is the need to construct the true shape. Make it fast. टेबल में చిన్న బిందులో ఉంది. ఏయమ్మా Students, have you copied the problem? Shall we move to the next? Okay, now all of you write a problem. A cone of base 40 diameter, cone base 40 diameter and 70 height and axis 70 rests vertically, rests vertically with its base on HP, with its base on HP. So next, if it is cut by inclined plane, if it is cut by an inclined plane intersecting the axis such that true shape is an ellipse of true shape is an ellipse of major axis 30 Draw its projections. So this is also the problem in such a way that he didn't give the inclination of the section plane. He just gives that the true shape is an ellipse of major axis 30. All of you try this problem. All of you just try. Let us see what your solution is going to be. We will discuss later on, no problem. All of you just do the rough work. How is it visible? Is it visible now? Just wait a second. Is it visible now, students? Is it visible? Just wait.
సార్ కొద్దిగా జూమ్ చేయండి.
Now is it okay?
ఎస్ సార్. ఎస్ సార్.
Okay. So had you do it? Had you do this problem? So this was as similar to as like as a trapezium. So which we see the top view is going to be a trapezium. Here the top view is going to be an ellipse which already gives the major axis. So once we know this major axis, in the top view we just have the two endpoints, the major points, and we simply project the two endpoints on the two end generators. We will obtain those joining of those two. We will obtain the section plane. Let us see. XY. So you already know that the base is going to be where the base is resting. The base is resting on HP. So top view gives the true shape of a circle. So let us do one thing. We just obtain our true shape on the top of the figure. Let us see. You just take my XY downwards. If this becomes XY, okay. So this was my cone of base in top view. Okay, you just take 8 number of equal divisions. Okay, let us say I will also take 8 divisions, no problem. A, B, C, D, E, F, G, H. So this becomes O1 of O2. So given height is 70, right? So the base diameter is given 40. So when you are supposed to see from the front, so this was step 1. Okay, so these points become A dash, B dash of H dash, C dash of G dash, B dash of F dash, and it is E dash. Generally for cone, you are going to join only end generators. Okay, but for here, I just take the remaining generators also for my reference. Remaining generators also. Generally, it is going to be taken only for the end generators. But while it is going to be sectional solids for obtaining the curve, we just take the referential generators also. I know that, so I don't know how this cutting plane is going to be and where it is going to be. Okay, but I know the true shape is going to be an ellipse of major axis 30 mm. So when it is going to be, if it is cut by a section plane intersecting the axis, cut by section intersecting the axis, such a way that the true shape is going to be ellipse of major axis 30. So that means from the center, I just take from 15 from here, 15 from here. I just mark these 2 points. If I extend these 2 points, if you extend these two, actually just get pen. So actually if you extend like this, it will come somewhere at here. Okay. So this becomes your pointer. This is D dash. In bracket it is F dash. Okay. Now if you just draw your cutting plane, which is going to be passing through these points, that becomes your section plane. So represent your section plane, which is going to be decadence. This becomes your VT. And now give the numbering, the points is going to be, you are going to divide 8 number of divisions, you obtain 8 points. So 1, this was 2, 3, 4, 5, 4 comma 6, 3 comma 5, 3 comma 7, and 2 comma 8. Okay. So whenever there are 2 generators, you will obtain 2 points. OA is one generator having 1 point. Next OB 2 point, OC third point, OD fourth point, OE fifth point. Again starting from here, on OE there is only one. If you obtain only 1 point. Next there was a hidden OEF, so it is 6, OG 7, OH 8. Okay. Now project the points to the respective positions now. So 1 point is to be on at here. This becomes your point 1. 2 point is to be on. So this is 2. This is 8. 3 and 4, which is known to be not supposed to cut the generator. It should coincide. Next, let us see 4 comma 6. So this becomes 4 and this becomes 6. Next 5. 5 point is to be on. At here itself, this becomes 5 point. Which are 1 and 5 on? Distance between points 1 and 5 is taken as 30. Why? Because major axis is given as 30. So I just take 1 and 5. Now let us see where your points are going to be 6 and 4, which are not to be obtained here. So project the points 6 and 4 onto the two slant edge. What is the two slant edge here? OE or OA. So if you just project those points, this becomes your 6 comma 4. So if you project the points onto the OE, so this becomes your point K. OK as radius Dana. OK as radius Dana. This becomes your 7. This becomes your, sorry, this becomes, this is 7. 6, 4 and 6. So actually this was 3 comma 7. Okay. Now join all the corners. Like this. Okay. So that should be drawn with hatching. So while your observer is from the top, this portion is removed and this is going to be your retained portion. This is retained portion. So from here also this was going to be the bottom base is visible, so it is retained portion. Okay. Now how can we obtain our true shape? We already know that draw the parallel line to vertical trace and draw the perpendiculars from all the points and mark the distances from the old reference line. Okay. Next 2, here it is 2. Next, so it's 3, 7, 4, 6. So when you join all these points, you will obtain an ellipse. So this becomes your true shape. So this was your front view. So where your height of the solid is given as 70. This was sectional top view. So which was such a simple problem. Students, is it clear? What is it, VT? So VT is a line which is going to be inclined. I didn't know my VT is straight or inclined. How can I obtain my VT? I just know the major axis is going to be given as 30. So I just consider these 2 points, the distance between these two are 30. From here I just projected, it cuts the cone at here. From here if I just projected, it cuts it here. These becomes your 2 end points. If I join these two, that becomes your cutting plane. And now this becomes your inclination with the, so this is some theta. Okay, students, I don't know initially how much it is inclined. I only know the top view is going to be, major axis of the top view is 30 mm. So I just consider the major axis on in between AE. So from the centers I take 15 from here, 15 from here. I just put 2 points. If I project to a point to here, project the point to here, I just get the 2 end points. If I join these two, I obtain my VT. Okay, students, how do you understand how I obtain my VT? Now you know how can you obtain your VT? Students, is it okay? Someone had raised that doubt. Is it clear for you? So someone had put their thumb down. So student, can you tell me what is your doubt? I will explain you. So here also I just 3.3 comma 7 points which are going to be obtained on GC. If I just project that points, it should coincide with the edge OC and OG. For that one, I just project my points on the true slant edge, and from there I just project my points to the their position. Students, can you repeat that question? What was that? What was that question that someone had raised? Can you type it once again? Student, anyone can you type that message? So anyone have any doubt? Can you kindly type the message? Students, have you understand how the 3 comma 7 points are obtained? 3 comma 7 points. Yes. Okay, no problem. I will explain you once clearly. If you see this was your figure actually. XY. So this was the circle. Okay. The points are going to be 3 comma 7 at here. Okay. By 3 comma 7 is this is going to be O dash. This is C dash of G dash. So this becomes GC. If I project my points, it should coincide to here. It doesn't coincide, it is not supposed to cut the points. So here in this case, I know the true slant edge. What is my true slant edge? What is my true slant edge? In this problem, OE, OA, OE, OA are the true slant edges. So I project my point to the true slant edge. That means draw a horizontal line parallel to XY. So the points comes to here. This becomes 3 comma 7 now. So if you project these 3 comma 7 to here, that is on OE. On OE, now this becomes your 3 comma 7. Okay. Now O as center, this has radius. Let us take it as some K. Okay, students, for your friends, let us take it as some K. If you project this, it comes K. O as center, O as radius Dana. O as center, O as radius Dana. This point becomes your 3. This becomes 7. So if it is 3 comma 7, so it becomes 3, 7. It comes 7. It becomes O as center, OK as radius. Is it clear now? Student, is it clear? I just transfer my points 3 comma 7 to the true slant edge. Here OE and OE are the two slant edges. So I project my points to the true slant edge. So from there I project it from the top view. From where there I project it on the top view, it comes to here. Now O as center, O as radius, draw an arc. O as center, O as radius, draw an arc. That becomes your 3 comma 7. Okay, students, is it clear? Okay, I just stop my session, today's session right now at here, in this junction. And tomorrow we will discuss the remaining problems, and tomorrow we will start the section development of surfaces also, developments. Okay, tomorrow we will see another 2 or 3 problems in sections of solids, and then we start the developments of surfaces. Okay.